Welcome to Engineers Academy. Subscribe to my channel and click on the bell icon to receive the notification for the upcoming videos. Now I am going to solve this problem 2-3 from Hibbeler 14th edition. So in this problem it is said they determine the magnitude of the resultant force Fr is equal to F1 plus F2, right? So we are required to find the magnitude of the resultant force and its direction. And the direction should be, the angle should be measured counterclockwise from the positive x-axis, right? So in this problem we are given this F1 which is making 30 degrees with the positive y-axis, and this F2 is given which is making 45 degrees with this positive x-axis, right? So if we apply the parallelogram law of addition, so we will have to draw that parallelogram. In order to draw a parallelogram, so what I will do, I will move this force, this F1 force, until the head of this second force, right? So I will place this F1 on the head of F2, right? So I will write that this is F1, right? And the F1 magnitude is 250 pounds, which is given, right? So this is given. Now in order to complete the parallelogram, what I will do, I will copy this F2 force with the same orientation and I will place it on the head of the F1, right? So this completes our parallelogram, and this is F2, and the magnitude of F2 is 375 pounds, right? So now what will be the resultant? So by head to tail rule, this will be the resultant, right? So let me draw that resultant. So the resultant will be from the tail of the first vector to the head of the last, right? So this is the resultant, this green one. So this is the first vector, so the tail of the first vector with the head of the last, so this is the resultant. Let's suppose if this is the x-axis is positive and this is the negative y-axis, right? So this is that F2. So now we know that this F2 is making 45 degrees with the positive x-axis. This is given, right? And since this is F2, so this is again 45 degrees, right? So this is 45 degrees, and this angle is 90 degrees. This whole angle is 90 degrees since these axes are perpendicular to each other. So if this is 45, so then this angle is also 45 degrees, right? And if this is 30 degrees, so then this angle is also 30 degrees. These two angles are alternate angles, so this is 30 degrees, right? So now what will be the included angle between F1 and F2? So this whole angle is the included angle between F1 and F2. So let's suppose that this angle is alpha, right? So alpha is equal to 30 plus 45. So alpha is equal to 75 degrees, right? So the included angle between F1 and F2 is 75 degrees. Now we are asked to find the resultant magnitude, so we can apply the cosine's law. We know F1 and F2 and the included angle between them. So if I apply the cosine's law, so then R square will be equal to F1 square plus F2 square minus 2 F1 F2 cos of alpha. So if we put the values, so F1 is 250 pounds plus F2 is 375 pounds minus 2 into 250 into 375 into cos of alpha, and alpha is 75 degrees, right? And if we take the under the root 2, so we will get the resultant magnitude. So let me solve this. So R comes out to be 393.2 pounds, right? So now we know the magnitude of this R. Now we are asked to find the angle of this resultant with the positive x-axis, right? So we are required to find this angle, right? This angle is required. Let's suppose that if this angle is theta, so we are required to find this theta. Let's suppose that this angle is beta, right? So now if we somehow find this beta, so then this angle, this whole angle is 90 degrees, right? So this 30 degrees plus beta plus this theta, this all is equal to 90 degrees, right? So I will write that 30 plus beta plus theta, so this is equal to 90 degrees, right? all of these angles are complementary angles, right? So 30 plus beta plus theta is equal to 90 degrees from here, right? So if I join this, so this is 90 degrees. So now if we find this beta, so then theta will be equal to 90 minus beta minus 30 degrees. So in order to find this beta, we will apply the sines law in this triangle, right? So now if I apply the sines law, so if I write that sine of beta divided by the magnitude of the opposite side, so this is the opposite side to beta, right? So I will divide it by f2 equals to, and let's suppose if I write that sine of alpha, so the opposite, this is sine of alpha, this is alpha, right? So sine of alpha divided by r, right? So this is the opposite side, so I will divide it by the resultant magnitude. So then beta will be equal to sine inverse f2 sine of alpha divided by r. So beta will be equal to sine inverse, and f2 is 375 sine of 75 degrees divided by 393.2, right? So if I solve this, so I will get beta angle. So beta comes out to be 67.10 degrees, right? So using this equation we can find theta, right? So theta is equal to 90 degrees minus beta, so beta is 67.10 minus 30 degrees. So if I solve this, so this will be the angle of the resultant with the positive x-axis. So this theta comes out to be minus 7.1 degrees, right? So this angle is with the positive x-axis, right? But this is in the clockwise direction, right? So we are asked to determine the angle with the positive x-axis in the counterclockwise direction. And since this angle is minus 7.1, so as this diagram was not drawn according to the scale, so this means that the actual resultant is making minus 7.1 degrees, right? So what is meant by this? So if I draw that resultant, the actual resultant, if we draw these forces according to the scale, so then this will be the resultant, right? Somewhere here. So this would be the actual resultant, and this is that actual theta representation, and this angle is in the clockwise direction. So that is why there is a minus sign, right? So this is minus 7.1 degrees. Now we are asked to find the angle with the positive x-axis, right? So we are required to find this angle, right? This whole angle. So this is the positive x-axis. Let me draw that diagram here. Let's suppose if this is the positive x and y axis, let's suppose if this is positive x and this is positive y, and this is that resultant which is making 7.1 degrees. Let's suppose this is that resultant, right? And this resultant is making 7.1 degrees in the clockwise direction, right? So we are asked to find this angle with the positive x-axis in the counterclockwise direction. So this is the counterclockwise direction. So what will be this angle? Let's suppose if this angle is alpha, right? So alpha plus theta will be equal to 360 degrees, right? So this complete angle is 360 from positive x-axis to back to this point, right? So if this is theta, right, so phi plus theta will be 360 degrees, right? So this phi will be equal to 360 minus theta, right? So we will not use the minus sign, right? So this will be phi will be 360 minus 7.1 degrees, right? And phi comes out to be 353 degrees approximately, right? So this is the angle of the resultant with the positive x-axis, and this angle is measured counterclockwise from the positive x-axis, right? So this is the phi angle of the resultant, and this is the magnitude of the resultant. So this is the solution of this problem. I am going to solve this problem 2.7. In this problem it is said that resolve the force F1 into components acting along the U and V axes and determine the magnitudes of the components. So this is the F1 force and we are asked to find the components of this F1 along this U and V axes, right? So these are the oblique axes, so we are required to find the components of this F1 and this F2. In this second question, this 2.8, we are asked to also find the components of this F2 along this U and V oblique axes. So first I will find the components of this F1. So to find the components of this F1, what I will do, I will draw a line parallel to this V axis and I will move this line until the head of this F1, right? So I will place it here and then I will be able to draw the component of this F1 along the U axis, right? So this will be the component of this F1 along the V axis, right? This line is parallel to the V axis, and if we want to draw the component of this F1 along U axis, so then this will be that component. So we can write that this component is F1V and this one is F1U, right? And since this angle is 30 degrees and this line are parallel, so if this is 30, so then this is 30 degrees, this is alternate angle, so we can write that this is 30 degrees and this is 75 degrees, so this whole angle is 75 degree, so then this whole angle is 75 degree, and if this angle is 30, so then this angle is 75 minus 30, so then this is 45 degrees, right? So this is F1. So now we have this triangle and F1 is equal to 4 kilonewton. So to find this F1U, so what I will do, I will apply Sine's law, right? So I will write F1U divided by the sine of the opposite angle, so this sine of 30. So I will write sine of 30 degrees and this will be equal to F1. So this F1 is known, which is 4 kilonewton, right? So let me write F1 divided by the sine of the opposite angle. So what is this angle? So this angle is 180. The summation of all the angles of a triangle is 180. So if we subtract both of these, so this is 180 minus 45 minus 30, so then this comes out to be 105 degrees, right? So this angle is 105. The angle opposite to the F1 is 105 degree. So I will write sine of 105 degree. So if I solve this, so this will give us the component of F1 along U. So F1 is 4 kilonewton, so I will write 4 and I will multiply this with sine of 30. So sine of 30 divided by sine of 105. So I will solve this a bit later. So now to find F1V, again we will use the Sine's law. So F1V, this is F1V, right? This component. So we will divide it by the sine of the opposite angle, so that is 45. So I will write sine of 45 degree and this will be equal to again this F1 and F1 divided by sine of 105 degrees. So F1V is equal to F1. So F1 is 4 multiplied by sine of 45 divided by sine of 105 degree. So if I solve this, so we will get the magnitudes of the component of F1 along U and V axes. When I solve this, so we get this F1U as 2.07 kilonewton and this comes out to be 2.93 kilonewton. Now I will solve this 2.8 problem. So in this problem it is said that resolve the force F2 into its components acting along U and V axes and determine the magnitude of the components. So now we will resolve this F2 into its components along U and V. So again let me clear this diagram, right? And now if I move this line which is parallel to the V axis, and if I move this line and I place it on the head of this F2, right? So then one of the components will be in this direction, right? If I place it, and let me remove these, right? So now if I resolve this force into its components, right? So one component will be from here to here. This will be one component, right? And then this one will be another component. So this component is acting along u, so then this will be F2u, and this one will be F2v, right? And this angle is given, this is 30 degrees, and since this is the u, this is that u axis, and this line is parallel to that v axis, so we can write it that this is v dash, right? So the angle between u and v axis is 75 degrees. So this is 75 degrees. This is also 75, and this is also 75 degrees. So now we can find this angle as well. So this angle is equal to, if this is, let's suppose, theta, so then theta is equal to 180 minus 75 minus 30. So this is equal to 75 degrees, right? So this is theta. So now we know these three angles, right? So we can find the F2u component, right? So if I apply sine law, so then if I apply sine's law, so then F2u divided by the sine of the opposite angle, so this is sine of theta, right? And sine of theta is 75 degrees. So I will write sine of 75 degree, and this will be equal to F2. So this is that F2 divided by sine of the opposite angle, so this is 75, right? So sine of 75 degrees. So this will cancel out, right? So F2u is equal to F2, and F2 is 6 kilonewton, right? And if you want to find F2v, so then F2v divided by the sine of opposite angle, right? So this is F2v, and this sine of 30, right? So we will write divided by sine of 30, and this will be equal to F2 divided by sine of 75 degrees. So F2v is equal to, F2 is 6 kilonewton, sine of 30 degrees divided by sine of 75 degrees. So if I solve this, so we will get F2v magnitude. This comes out to be 3.11 kilonewton, right? So these are the two components of F2 along u and v oblique axes. So this is the solution of these two problems. Hello students, welcome to Engineers Academy. Now I am going to solve this problem 218. In this problem it is said that determine the magnitude and direction of the resultant Fr, which is equal to F1 plus F2 plus 3. So we have to find the resultant of these three forces, and it is said that find the resultant by first finding the F dash resultant of F2 and F3, and then forming F dash plus F1, right? So we have to find the resultant in two steps. So now as we can see that we are given the angles of this F1, F3 is horizontal and F2 is making 20 degrees, right? So this angle is given. So we can find this angle. We can find this angle of F1 with the horizontal, right? So this angle is equal to, if we apply tan theta, so tan theta is equal to, if we apply tan theta to this triangle, so then this is 3 divided by 4. So then theta equals to tan inverse 3 divided by 4. Theta comes out to be 36.87 degrees, right? So this is the angle of F1 with the horizontal, right? Now first we have to find this F dash, right? So F dash is the summation of F2 plus F3. So now if I draw the positive x and y axes, right, and let's say that this is our F3, which is 50 pounds. Let's say that this is F3, which is horizontal, and F2 is 20 newtons, right? So let's say that this is F2. So let's say that this is that F2 which is 20 Newton. So I will write 20 Newton, and this F3 is 50 Newton, right? So then the resultant will be F dash. So we are given that F2 plus F3 is F dash, right? So let me draw that resultant. So let's say that this is that resultant from the tail of F3 to the head of F2. So this resultant will be F dash. So this F2 is making 20 degrees with the vertical, right? So if we represent that angle as well, right? So if I draw a vertical line here, so this angle is 20 degrees which is given, and this is, remember that this is F2, right? So if this is 20 degrees and this line is horizontal, so then this whole angle is 90 degrees. So this means that this angle is 90 minus 20 degrees. So we can write that this angle is 70 degrees. So the angle between F3 and F2 is 70 degrees, and we are asked to find this F dash. So now we can find this F dash by using cosine's law, right? So you can write that F dash square equals to 50 square plus F2 magnitude is 20 square, right? So 50 square plus 20 square minus 2 into 50 into 20 cos of the included angle, so which is 70 degrees. And if we take the square root, so this will give us the F dash magnitude, which is the resultant of F2 and F3. So F dash comes out to be 47.07 newtons, right? So the resultant of F2 plus F3 magnitude is 47.07, right? So now we will add, to find the Fr, we will add F dash plus F1. Before finding the Fr resultant, first we have to find this angle. Let's say that this angle is, let's say, alpha. So we can find this alpha by using sine's law, right? So if I use sine's law, so then sine of alpha divided by the size, the magnitude of the opposite side, which is F2. So F2 is 20, and then sine of 70 degrees, and the magnitude of F dash, which is 47.07. So alpha equals to sine inverse 20 sine of 70 degrees divided by 47.07. So this will give us that alpha angle, the F dash angle with the horizontal, right? So let me find this. Alpha comes out to be 23.53 degrees, right? So this angle is 23.53 degrees. So now we have to find the resultant of F dash and F1, right? So again I have to draw another diagram. Let's say that we have this axis now, and F dash, let me put this F dash here, right? So this F dash is making alpha angle, right? So this F dash is making 23.53 degrees. So this angle is 23.53 degrees, and this F1 is making 36.87 degrees. So if we draw that F1 as well, so that F1 is here, right? So which is like this, and its magnitude is 30 degrees, right? So this is that F1, its magnitude is 30 degrees, and it is making how much angle? That angle is 36.87, right? So this is 36.87, right? So now we have to find the resultant of both of these. So now if we add both of these by using the head to tail rule, so I have to place this vector on the head of this F dash, right? So let's say that this is that F dash and this is that F1, right? So this will be the resultant of both of these, right? So from this point to this point, right? So this is that resultant Fr, right? And this angle is 23.53. And if I draw another horizontal line here, if I draw a horizontal line here, so then this complete angle is how much? So then this complete angle is 36.87, right? So we know this. So this complete angle is 36.87, right? And this angle, the f dash is making 23.53 degrees with the horizontal, right? So we can write that this is f dash and this angle is 23.53 degrees. So what about this angle? So this angle will be 36.87 minus 23.53. So this means that this is f1 and this angle is 36.87. Let's say that this angle is beta. The angle between f1 and f dash is beta, let's say. So then beta is 36.87 minus 23.53 degrees. So beta comes out to be 13.34 degrees, right? So this is the included angle between these two. So now we can find fr, since we know the magnitude of f1 and the magnitude of f dash by using the law of cosine's law. So then fr will be equal to f1 square. So f1 is 30 plus f dash square. So f dash is 47.07 square minus 2 into 30 into 47.07 cos of the included angle, which is beta, that is 13.34 degrees, and we will take the square root. So fr comes out to be 19.17 Newton. And now if we find the angle of fr with the horizontal, so let's say that this angle is gamma, let's say, right? So let's say that this fr is making gamma angle with this positive x-axis, right? So this means that this whole angle is 23.53 plus gamma, right? So let's say that this angle is 23.53 plus gamma, right? So now we have the magnitude of f1, we have the magnitude of f dash, sine 23.53 plus gamma equals to, and we have to take the ratio, so the opposite side is f1. So f1 magnitude is 30, and now we know the magnitude of fr and the opposite angle, we know beta as well, right? So beta is 13.34. So sine of 13.34 degrees divided by 19.17. So this will give us this gamma angle. So now 23.53 plus gamma will be equal to sine inverse 30 multiplied by this. So 30 sine of 13.34 degrees divided by 19.17. So when we solve this, so then 23.53 plus gamma comes out to be 21.16, or we can write that this is 21.17, right? So we can solve this. So this means that if we want to find gamma using this equation, right, so then gamma is equal to 21.17 minus 23.53. So this is greater than this. So this means that this angle will be negative, right? So 21.17 minus 23.53, this gives us minus 2.36 degrees, right? So this minus means that this angle is measured from x in the clockwise direction, right? So if this is the x-axis, right, so then the angle measured is like this, right? So this is clockwise angle, this is minus. So this means that actual fr is below the x-axis, right? So this diagram is not up to the scale, right? So if we draw the f1 and f dash according to the scale, up to the scale, right, so then fr will be making 2.36 degree angle with the x-axis, but that angle will be in the clockwise direction, right? So this is the solution of this problem.
All right, so this is problem 280. We're given this bracket and it has a few forces on it. And what we're looking to do here is find the resultant force. So adding all these two forces together, the magnitude of that force, and all the coordinate direction angles of the resultant force. So let's get started with that. Okay, so I'm going to make sure I can still see my image here. So let me move that down a little bit. All right, about right there. Okay, so let's make sure you can see that too. Something like that. Okay, let's get started here. So we need to express these first in Cartesian vector notation. So let's start with F1 here. So F1 in the x direction. So if to get the x direction here, how do we do that? All right. Well, if we take the cosine of 35 degrees here, that's going to be the projection on this line here, okay, of F1. And then we want to project that all the way on to x here. And we know that this angle's 25. So what we could do is cosine of 35 and then sine of 25. So we know the total magnitude is 250, so 250, and that's going to be multiplied by, let's see, cosine 35 degrees, sine 25 degrees, and that's going to be in the I direction. And then we add plus the y direction, which will be cosine of 35 degrees, and then cosine of 25 degrees. So what I'm doing here is taking the cosine, and that gets the projection on this line, and then taking the cosine of 25, and that should project it on the y-axis there. And that's in the j direction. All right. And then lastly, we need to do the z direction. All right, so how do we do that? Well, we know that it's 35 here, but it's going to be downwards in the z direction if it's pointed upwards here. So we just have negative sine of 35 degrees in the k direction. All right, so this is the x, this is the y, and then this is the z. If we want to simplify that, we have, let's see, 86.55i, and then 185.6 j, and then negative 143.39 k. So that's that vector. And then F2, then we will do the same sort of thing. So F2, we know the magnitude is 400. So in the x direction, all right, so x is out here. We will do, and we have the direction for that. We have that angle as 120 degrees. So that's just cosine 120 degrees in the I direction. And then we have, in the y direction, we have that which is cosine of 45 degrees, cosine 45 degrees in the j direction. And then lastly, in the z direction, we have 60 degrees. So that's plus cosine 60 degrees in the k direction. So again, distributing this out, the 400 out, we come up with negative 200 I plus 282, let me write that a little neater, 282.84 in the j, and then plus 200 in the k. So now we have these equations for both F1 and F2. To find the resultant vector, all we need to do is add those two together. So taking F1 and F2 together, so we have F resultant R is equal to F1 plus F2. And if we do that, we come out with negative 113.45 I plus 468.44 J plus 56.61 K. All right, so this is our F1 plus F2. For our answer, you probably want to round these to 3 significant figures. Now we need to figure out the magnitude. All right, so I'm just going to circle this because this is one of our answers as long as it's rounded to 3 significant figures. So FR, the magnitude of that is just the sum of the squares of all these components and taking the square root of that. So we have a negative 113.45, that value squared, plus 468.44 squared, plus 56.61 squared. And then all of that, take the square root of all of that. And our total magnitude then comes out to roughly 485 newtons. So that is our magnitude. And lastly, maybe the most tricky part is the angles. All right, it wants the coordinate direction angles. So we have this vector, whatever direction it points. I'm not even going to guess, maybe something like here. And it wants the angles in between this vector and the x-axis, this vector and the y-axis, and this vector and the z-axis. And those are alpha, beta, and gamma respectively. So, all right, so to figure out alpha, we have cosine alpha. This is the direction cosine here. Cosine alpha, we would want that to be our FR in the x component divided by our magnitude FR here. So that's what that equals. And all we're doing here is if you have a triangle, right? And we're looking for this angle alpha, right? We know that cosine is adjacent over hypotenuse, right? So this is FRX here, and this is FR. I know this is a 3D problem, but this is pretty much what we're doing. So we have FRX, which is negative 113.45 divided by our magnitude, which is 485.3 if we leave the decimal places on it. And what that comes out to be is alpha comes out to be 104 degrees. So that is one of our direction, coordinate direction angles. Now we do the same thing for cosine beta, and that is just going to be FRY over the magnitude FR. So that is 468.44. 468.44 divided by 485.3. And then we divide that out, take the inverse cosine just like we did here. And beta comes out to be 15.1 degrees. And now I think you get the idea. The last one is cosine of gamma, and that's the resultant in the z direction divided by the magnitude. And doing this and then inverse cosine here, we have gamma is 83.3 degrees. So that is problem 280.